Population and sample means are generally pretty straightforward in terms of their calculations. So if it's a population mean or a sample mean, all that I have to do is just sum up my x's and divide by the number of values that went into that sum, so the number of scores. This does, however, get a little bit challenging, or there's potential for making an easy mistake when you're looking at a frequency distribution or a frequency distribution table. Let's say, for example, I did a quick survey outside the bookstore and I asked people, how many textbooks did you buy today? And so maybe somebody says 0 books. So there's one person that says they didn't buy any books. They didn't find what they were looking for. And 2 people bought 1 book, and 3 people bought 2 books, and maybe 2 people bought 3 books, and 4 people bought 4 books. If this is being treated as a sample, certainly isn't everybody who bought a book at the bookstore, I would be looking to my sample formula, and it would be a simple, easy mistake to try and do what I've done in other videos, to just sum up my x's by adding 0 plus 1 plus 2 plus 3 plus 4. This would give me a total of how much? I would have 1 plus 2, that makes 3, another 3 makes 6, 4 makes 10. This would be a sum of x of 10. And then after that, you may notice that there's a little bit of an issue when you go to find your sample size. You might simply think that it's 1, 2, 3, 4, 5 because you had 5 x's, and then you would get a mean of 2. Now, both of these values that I've used are wrong. The 10 is not truly the sum of x, and the 5 does not represent how many people were in the sample. The reason for that is that I've ignored my frequencies. And to really show how this works out, to really show where the mistake was made, it's better to take my data away from being in a frequency distribution table. So take the data out of the table and just represent it as raw data. So there is 1 0, there are 2 1s. I have 3 2s, so 1, 2, 3 2s. I have 2 3s, and I have 4 4s. 1, 2, 3, 4. Now you can see that we definitely don't have 5 scores in our sample. Instead, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a total of 12 scores. So when I find my sample mean, it's going to be over 12. Also, when I summed up my x's, when I summed up my scores, before, when I just added down this column here, I got a total of 10, which again is wrong because that ignores frequencies. It ignores the fact that there are actually 4 4s and there are 2 3s. So doing it as raw data here, it makes it easy to avoid that mistake. I've got 1 plus 1, that makes 2. Another 2 makes 4, 6, 8, and then there's 6 here. That brings me up to 14. And 18, 22, 26, and 30. So my sum of x, if I haven't made a mistake there, I'll double check that in a moment, is 30. Now how am I going to double check this? How am I going to make sure that it truly should be 30 over 12? And whatever that works out to be, I'll figure that out in a moment. Well, the way that we're going to do that is we're going to create another column. I'll do that here in blue. So I've got my scores as the x column, my frequencies are f, and then I'm going to do f times x. What I'm doing is I'm checking to see how much was contributed to this total, how much will be contributed by each x. 1 0, 1 times 0 gives me a total of 0. 2 1s, 2 times 1 gives me a total of 2. And so I've got this, I've got 2 1s. 3 2s makes a total of 6. So when I add these guys in, they add a total of 6. And 2 3s again gives me a total of 6. And 4 4s, that gives me a total of 16. When you sum this up, when you sum up this column here, you will get, well, first of all, it's obvious that you're going to get the sum of fx because it's the sum of what's in this column, but this truly is the sum of x because it does take into account how many of each one of your scores you truly have that are being hidden in this frequency column. So let's see what this works out to be. I've got 2 plus 6, that makes 8, plus 6, that's 14, plus 16, that does make 30. And so the sum of x is 30, so the mean truly is 30 divided by 12, and let's see what that comes out to be. 30 divided by 12 equals to 2.5. Okay, so this comes out to be 2.5. Definitely different than what I got by simply just adding up my x values and dividing by the number of x values that I see here. So if you have a frequency table, you're still going to be using the same formula. For a population, you would be using the sum of x over big N or capital N. For a sample, you're still going to be using the sum of x over small n. However, you have to understand that the sum of x is going to come from the sum of the column where you've done the frequency times x. Also, n, that will come up from summing up your frequencies. Remember how I counted this big list here of all of my scores? I counted 12 of them. You can get that too by summing up your frequencies. The sum of your frequencies is 1 plus 2, that makes 3, plus another 3 makes 6, 2 more makes 8, plus 4 makes 12. So the formula ends up being the sum of fx over the sum of f. You won't necessarily need to remember this. What you do need to remember, however, is to create this new column, x times f, or f times x. Use that to get your sum of x. So let me put that in there. So this new column here, that's where you're going to get your sum of x, not there, and you're going to get n as the sum of your frequencies. You should be practicing a number of these because this is exactly the kind of thing that you can expect to see on your first test, where you're going to be presented with a number of different frequency tables.